We thank you for this day. We thank you for this day. We thank you that you have given us the opportunity to be in this lesson. We ask you to help us concentrate and get what we are going to learn and never forget it. Amen.
Amen. Thank you so much for the word of prayer. Good afternoon, everyone, and thank you so much for joining. Today, our topic we are going to look at is work, energy, and power. So let me ask you to first write our topic for today, work, energy, and power. And I'm going to ask if you have heard of any of those words. You can raise up your hand and you share with us what you have heard about them, or in case you have any idea about any of those words. Just raise up your hand and then you can share with us. Work, energy, and power. Okay. Yes, Glenna?
I'm defining energy.
Okay.
Energy is the ability to do work.
Okay, energy is the ability to do work. Thank you. That is correct. So for her, she has heard about energy. Yeah. So those are the things we are going to be looking at. We are going to look at work, energy, and then lastly, we shall look at what power is. Okay. And yes, Jordan.
Yeah, me, I want to talk about work.
Okay.
Work is the product of force and the distance moved in the direction of force.
Okay, good. Product of force and then the distance moved in the direction of force. Good. Ayo.
Is the rate at which work is done.
Okay. I beg your pardon? Ayo, come again?
Power is the rate at which work is done.
Okay, power is the rate at which work is done. Okay, so those are our three major words that we are going to look at. Then lastly, John. Yes, John.
Work, work, work is the force applied to an object that causes it to move.
Okay, the force that you apply to an object to make it move. Okay, very good. So good enough. You have idea on each and every word. Okay. Our competence is that. So I'm going to ask you also to write your competence down. Competence is what you must be able to do by the end of the topic. That when you finish the topic, there are certain things that they expect you to have mastered and you can be able to do. So whenever you finish a topic, you have to go back and reflect and ask yourself, am I able now to define what work is? Can I be able to relate energy, work, force, and power? Yes. So that is what we call the competence. What can you do? That from this topic, I can do this. From this topic, I can do this. Okay. I think people have finished. Okay. Then we have what we call the learning outcomes. So what do we expect to know by the end of this lesson? So by the end of the lesson, I will expect each one of you to be able to define work. You must be able to identify situations in which work is done and in which no work is being done. Yes, Daniela?
Excuse me, teacher.
Yes.
Which topic is this?
Work, energy, and power.
Can you please take back to the competency?
Okay, I'm going to go back.
Thank you.
Okay, you can complete the competence members. Okay, I think now people have finished. So I was looking at the learning outcomes and we said the first one, you must be able to define work. You must be able to identify those situations in which work is done and in which work is not done. Then the last one is knowing and being able to use the relationship between work, force, and then the distance that is being moved. So those are the key things we are going to be looking at in this topic or for our lesson today. Okay, I have the first activity. So the first activity, I'm going to ask those who can turn on their videos to do so. In case you can turn on your video, feel free. Given that where you are, it is a conducive environment, but also you must have a good background. Then the next thing I'm going to ask you is you stand. So I expect now everyone to stand and hold your book in your hand. Yes, hope you are doing. I'm going to turn off my screen here and then we spotlight a few people that are doing this activity. So this is what I expect you now to do. I expect you to be up and you are holding your book. Okay, so allow me to stop sharing and we see whether we have some people who are doing so. I'm going to spotlight. Let me spotlight Bridget. Bridget, I'm spotlighting you. Let me spotlight Daniela. I want to, who else? I can spotlight Elisa. Who else? I'm seeing that I want someone holding a book. Same is here. Okay. Hold your book. Now, are you seeing those people? They're holding their books. Now, I want you to tell us, someone you can raise up and you tell us whether are you doing some work or you are not. Just holding your book. Is there any work that you are doing or not? Feel free to raise your hand. In fact, let me allow you to unmute. So feel free to unmute and you tell us. Are you doing any work? Bridget, you can unmute. Okay, we can start. Kwagala, you can. Okay. Bridget, unmute.
Which I'm doing.
You are doing according to Bridget. Daniela. Kwagala.
Me too.
Yes, I'm doing some work.
Okay. Asimwe, unmute and tell us. Are you doing some work?
Yes.
Okay.
Yes.
You are doing.
Yeah.
Okay. Okay. Now, I want you are going to get that book of yours. Move it
Yes.
up and down. Move it up and down. Then you are going to tell us, are you doing some work or not?
We are
I'm doing
doing.
some work.
You are doing some work. What about Kwagala? What about Bridget?
Yes, teacher, I'm doing.
You are doing. Okay. Okay. So now we are going to go back now to our lesson. Now we have done two things. The first one, you were just holding your book
Yes.
and then you were doing. Now I want, before even we leave, Bridget, you are telling us that you are doing work, kwagala, and asimwe. What is the reason that you are basing on to say that you are doing some work? Asimwe, you can unmute. What are you basing on to say that you are doing work?
I am focused and writing what you are saying and learning.
Okay. Then what about Bridget?
Pardon, sir?
Yes. What are you basing on to tell us that you are doing some work? There is some work that you are doing that is being done.
What are you basing on?
Kwagala, do you have a reason?
Yes.
Do you have a reason that you are basing
Yeah.
on to say that you are doing some work?
Yeah.
Uh-huh.
Whatever you send, whatever you put on the screen, I write it.
Okay. Okay. So we are going to go back to our lesson. Yeah. So now, what you are doing, yes, is what I want us now to learn today. Yes. Under what circumstance should we say that someone is doing work, and under what circumstance is someone not doing work? We may have people here who are not doing any kind of work, and we may have people that are doing work. Now, this was the activity. When you notice that at first I told you to have your book, and after having your book, you notice that I asked you, so now when you are holding your book, like the picture below, you are not doing any work. So when you just hold your book stationary, a book, we shall call it an object. So whenever you hold it and it is not moving, it's not doing any, like holding it stationary, there you are not doing any work. When you are holding your pen and you are not writing, you are not doing any work. So for something to be called that you are doing work, it means that something must be able to move and you must apply a force. So those are the two things we base on to say that you are doing work or you are not doing work. So the first thing we always look at is that, is there any kind of movement? If there is no movement, then is like when you look at the book, initially the book was at this point here. Then the gentleman, or you remember you were holding your book, you had now to move up. So meaning that there is some force that you applied for the book to move up. So you moved up through a force. But still, when you look at the distance, there is some distance that has been covered from the initial point to where the book is. Now that is what you call distance. So if those two things all exist, what you call force and what you call distance in the direction of the force, then we shall say that there is some work that you have done. But you just holding a book doesn't mean that you are doing work. You having your pen in your hands doesn't mean you are doing work. Seated watching TV doesn't mean you are doing work. So for something to describe it that you are doing work, we expect to see some movement. We expect to see the force being applied in order for you or for you to be qualified to be called that you are doing some work. Kindly let me know through the chat whether we have picked that point of when we have to say that there is work being done and there is no work that is being done. Kindly just say
Excuse
yes.
me, teacher.
Yes, we're on the same page. Yes, John.
What if there's movement or motion, but when it is not in the direction of force?
Then now that one, we shall also disqualify it.
Oh, okay.
Yes.
Thank you, sir.
Yes. But now that one, there are times, if they are not in the same direction, there is something we do about it. That one we call it resolving and the rest of that. But that one we shall look at. That one it is at a higher level. Okay. Members, are we on the same page? Let me know through the chat. You can just type in the chat that yes, we are on the same page. Okay, in the chat, Ethan is saying yes. Okay, okay. Yeah, seems we're on the same page. Good. Now we are going to continue. Now, for the next two slides, you are going to describe the action in each picture and state whether work is being done and why or why not. Okay. Yeah, for you, you just raise up your hand, you tell us this picture, and then you give us the reason. Raise up your hand, and then, I'm going to start. Yes, Ethan.
I'll go for the fourth picture.
Mm-hmm.
So the lady is raising a heavy, is raising an object, showing that there is force
Mm-hmm.
acting. So there is work acting there.
Okay, perfect. Thank you, Ethan. Kwagala.
I would go for the third picture
Mm.
where the child is swinging. Like there's
Mm-hmm.
work done.
There's work done. What are you basing on?
He or she moved forward and yeah.
Forward. Okay, good. And they had to apply force. Okay, good. S, Ethan.
I want to say like picture 2, which is on
Mm.
top of the weightlifting.
Mm.
Like this one is brick making. He's
Mm.
applying force on the mud and
Mm.
over moving it, like, which is creating like some work.
Okay, good. Thank you. Nancy.
I'll go for the first picture
Mm.
because there is some force
Mm.
between there is some force carried out when those
Mm.
children are digging.
Mm.
Yeah, so that means that there is some work being done.
Okay. Okay, thank you, everyone. We have more. I go to Elisa now.
I go for picture 3 because the kids are dancing, like they are moving their bodies like from one place to another.
Okay. Okay. I go. Calvin.
Yeah, I would say picture 1 because that guy he climbed in the tree to pull himself upwards. He's applying some force there.
Okay. Good. Jero. Jero. Okay. John.
I'll talk about the second picture.
Mm.
Since the students are stationary, there's no
Mm.
work done at that moment. Thank you.
Okay, very good. Thank you. Yes, Jero.
I'll go for the last picture because the children are moving their hands in a way that they are writing. So there is work done.
Okay, then the last one, who's coming? Greenfield.
The first picture.
There's a picture.
The first picture.
No, there's a picture of a boy somewhere. The last one, this last one.
Oh, yeah, actually, he's using force to whatever he's pushing. Yeah, he's using force.
Okay, okay. Yes, Kwaga. Thank you, Green.
The boy who's on the side, I think he's pushing something.
Okay, okay, but what he's pushing is not moving.
So
I don't
there's
know.
no work. There's no work. Yeah.
There is no work that is being done. Whenever you push something or you pull something that is not coming, that is stationary, it means there is no work that you are doing. So whenever you see something, whenever you push now, like when you look at where you are seated and you try to push that wall, it will not move. So that means that you are applying a force, but there is no movement of the object. So whenever the object is not moving, then it means that you have not done work. Hope that is okay. Yes, Bridget. Bridget? Okay. Hope that is very, very okay. So whenever you push something and there is nothing like movement, it means that one, yes. So we are going to look at now what we call work. But let me first give you a number of scenarios such that we can be able to distinguish what we mean by doing work and not doing work. So take an example. When you push a car and the car starts moving, that one you are doing work. However, if you push this car and the car fails to move, it means you have not done work. You have applied the force, but that force has not made the object move. So means you have not done work. When you lift a weight, the weight will gain that one. It means that there is some work that is being done. But you just you holding weights without moving, it means that there is no work that is being done. So when you are writing a poem, it means that you are doing some work, but memorizing it doesn't mean that you are doing work. So doing work, we expect that there is a force you are applying and the object is moving. So that is very, very important. Okay. Okay, I think now we are good to continue. So let me ask you to first write what we are going to look at now. It's called work. So after writing your work, we are going to now dive. Now, understanding what work is. Now, work is only said to be done when a force moves an object through a given distance. When you look at my screen, we have a girl that is pushing a chair. And that means that this chair, when it moves, it is going to move in this direction here. And this is the new position for the chair. So what does it mean? I want to ask, is there any work that is being done? Raise up your hand and you tell us and you give us the reason. Yes, Ethan.
Uh,
Uh, yes, there is work being done because the lady is taking the chair from its original position and putting it in another position using force.
Good. Okay. Kwaga, do you have anything you want to add on, or John?
No.
Okay.
Yes, the
Uh-huh.
lady is pushing the chair, applying force to it, and the chair itself, the motion is in the direction of force. Hence,
Oh,
it's considered to be work.
very good. Yeah, that is very perfect. So whenever anything you talk about work, look at, is there a direction? The lady is applying force. So you are noticing that force and the direction or where the chair is going, they're in the same direction. So here we shall say that, yes, there is work that is being done. So may I ask you to first summarize something from that page? Summarize in your own words. Waga, you have a question? I'm seeing your hand up.
No, I don't.
Okay. So we are summarizing.
Excuse me, teacher.
Okay, I think we are finished to summarize. Okay, we are going to continue. Now we have another scenario. You let us know whether there is work being done or there is no work being done. So you raise up your hand and then you let us know. Okay, yes, Elisa.
There's no work done because although the man is using force, the wall isn't moving.
Wow, perfect. Gwenville.
There's no work being done because the wall ain't moving.
Okay, there is no work that is being done, much as the gentleman is putting in a lot of energy, is pushing, but what is pushing is not moving. So the force is being applied, but there is no movement. And wherever there is no movement, it means that work is not being done. So that one is very important. So for this, we shall say there is no work done because the force is being applied, but there is no movement. Okay, now, by show of hands, what are those two important things involved for work to be done? Is it Sayomi? Asemwepo? Oh. Aira? Makera?
Effort.
Effort. But in terms of work here, which word do we usually use?
Force.
Force. Good. Then the next word is?
I think movement of the object.
Movement of the object and then the force. So those two words are very important. Now we are going to summarize now what work is. Now when we talk about work, we are looking at the product. And mathematically, when you hear the word product means multiplication. That is the meaning of the word product. So it means that you are going to multiply the force you obtain times the distance. But here, the distance that is moving in the direction of the force. So here we shall always have force, then times the distance moved in the direction of the force. Or in case you don't want to use the word distance moved, then you can use the word displacement. So displacement means the distance you move in a specified direction. So whenever you are talking about work will use force and the distance moved in the direction. Alternatively, you can say that work is given by the product is force, then multiplied by the displacement. Because displacement moves that distance you are going to move, but in a particular direction. So let's write. Okay.
Hmm? When you have
members are writing. Okay, when you finish, you let me know through the chat. You just say, let's continue in the chat. I was saying that the gentleman that you were seeing on my screen is one of the people that were behind and in science, whenever you innovate, whenever you come up with something, the unit is called joule. So this gentleman here was called Joe. I wanted to So this gentleman was called Joe James Prescott. So he was the one that was behind work. But we have said that our work is always given by the force, then times the distance that is moved in a given or distance in the direction of force. But we know that the SI unit of force is a Newton. And you know that the SI units of distance is meter. So meaning that the units of work is Newton meter. However, if Newton meter is the same as what we call joule. Yes, in brackets, you can put capital G. So this gentleman is the one that was behind it, and therefore that's why it is named after his name. And in science, when Joule is the name, whenever something is a name, then its symbol is written using a capital letter. When take an example, in case it is Newton, Newton is also named. So when I'm writing it, I write it in small letters, but I abbreviate it using capital N. So Joe is in small letters, and then the capital J is the symbol. So it is either Newton meter or joule, but it is the same. So you write the SI units. Okay. Okay. Have you finished? Okay. According to the chat, members have finished. You can let me know through the chat. Okay, no. Okay, let's first finish. Okay, I think people have finished. Okay, done. Okay, we can continue. Now we are going to uh, uh, start looking, but also let's first write that activity. Let me hope members are writing. Okay, now looking at they're telling us that we have a woman who's pushing a grocery cart with 500 Newton force along the 7 meters. How much work is there in pushing the cart from one end of to the other? May I ask everyone to try and write your answer in the chat. Yeah, when you finish, write your answer in the chat. Okay, good. Those who have finished, you can share with us your answer in the chat. Okay, someone to take us through. Someone who wants to take us through. Okay, yes, Ethan.
Yeah, when they asked us a woman pushing a grocery cart with a force of 50 newtons along the 7 meter easel. So according to the working you gave us, you said that if you're going to find work, it is force times the distance used. So we're supposed to multiply the force, which is 500 newtons force, times the distance, which is 7 meters, which gives us 3,500 Newton joules.
Okay, which is good. So yeah, so that is what I expect members to have, because the question, they have given you the force, which is 500, and even they have given you the distance this particular lady is going to move. Okay. We continue. Not.
That rain. When did it affect here?
Okay. It seems people have obtained the answer. Okay, good. Yes, Jonathan.
They have said Ayo is rearranging her living room. She needs to lift a heavy box containing books onto a shelf 4 meters above the ground. The box weighs 300 newtons. Calculate the work done by Ayo when she lifts the box to the shelf. We said work is equal to force times distance covered by the object. So if I'm to multiply the 4 boxes times the 300 meters, I'll get 1,200 Newton meters.
Okay. I'm saying the answers are correct. Okay. Another one.
The work done on a force of
Okay, we'll first try it out. Okay, now looking through the chat. Okay, seems people have got the answer. People have got an answer. Okay. Who wants to take us through? Yes, Pusinje Dana. Oh, Pusinje Dana is not talking. Ayo.
Okay. Oh, okay, what I did, since work is force times distance in direction, The force was 150 newtons, and since the distance is usually in meters, I said 24 out of 100 meters. I cancelled the 0 with the 0 from 150, and then I divided 10 by 2, I got 5. I divided 24 by 2, I got 12. Then I divided 5 by 5, I got 1. I divided 15 by 5, I got 3. Then I got 12 times 3, which is 36 joules.
Thank you. Okay, thank you. And I think she's the only one. I've seen many of you. We are giving 3,600. Yes. So many of you are giving 3,600. You did not convert. One, whenever you are dealing with the units, please, a major unit can never go with a minor unit. So distance, it's SI unit. Remember always, once, in case it is mass, the SI unit is kilograms. In case it is distance, the SI units are meters. In case it is time, the SI units are seconds. So any other thing, whenever you are meeting them, you are doing your calculations and they're not in the standard units, then make sure you convert them back to the standard units. Otherwise, Newton and the centimeters do not match. Yes, Dana, and given? Is it a question? Okay. We go to another one. Okay, now I'm looking through the chat. Okay, it seems people are getting the right answers now. Those who have not got that one correct is one thing. When you are converting units, don't forget you have to set. So these are meters and these are centimeters. So 100. So in 1 meter, you have 100 centimeters. So how many meters were they in the other previous number? So you put your thing here. So I think it was 24 centimeters here. So in order for you to get, you cross multiply. So you have 24 equal to 100x. So divide by 100, divide by 100, which will give us that 2 point, the answer that she obtained. So for here, good enough. I've seen people have obtained 800 joules. Okay, perfect. Then this is the last one. Okay. Yes. Busenji, Busenje. Okay. Okay. Yes, Jonathan? Yes, Kwagala?
I was asking if I would explain after.
Okay, take us through.
So the question says 1,000 joules of work is done in raising a bucket of water from the bottom of the building of height 25 meters on construction site. Find the mass of the bucket underwater. So I think we get the 1,000 joules divide by 25 meters.
Okay, what are you finding?
The newtons.
The newtons are the units.
I mean the mass.
The mass. Now here, Kwagala, can you first tell us the formula?
Um, um,
Work is given by? Yes? Bethany, Kwagala, I think she dropped off. Yes, Bethany?
So I think you should divide 1,000 by 25 so that you can get 40.
You get?
40.
40. Uh-huh.
40 newtons. F times D. Work is equal to F times D. So giving you 1,000 out of 25 newtons, giving you 40 newtons.
Okay. Now here, you know that work is the force and the distance you move in the direction of the force. Now, what is going to happen? That since here we have a mass, we are raising something up. So meaning that there is some kind of weight. So here, or you can even feel free because you know that weight is also a force. So here you can see that instead of using, you can say weight times the what? The distance. But this special one, this is weight is a force. So in order, what are you trying to find? Is the weight that is being carried. How much weight is that? So here you have your 1,000 is equal to the weight, which is we can call W, times the distance, which is 25. So you divide by 25, divide by 25. So when you have your 1,000, divide by 25, you end up with 40. So we shall have our weight as 40 is equal to the weight which we are calling W. Well, now those who have used the force, you'll have what you call your force. But what are you very interested in? You are interested in finding out the mass. So you know that weight is given by mass times acceleration due to gravity. So here you say that your weight is 40 is equal to the mass of the bucket and water times acceleration due to gravity. So you have 40 is equal to 10m, divide by 10, divide by 10. So you end up with mass of 4 kilograms is equal to the weight. Is equal to the mass. But the SI units for mass are kilograms. So now I will say that mass of the water and a bucket is equal to 4 kilograms. Can I know through the chart whether we're on the same page? Okay. Okay, some people we are not yet. Now I repeat. Remember what they want you. Remember you have a bucket. This is our bucket that is carrying water. And you are taking it up there. You are taking it up. Now they're asking you, how much water and the bucket do you like you are using? How much, what is the weight of that water that you are carrying out? But here they have given you the amount of work that they're doing, and they have given you the distance it moves. Meaning the first thing you need to know, what is the force that you have applied? So you can say now, work is given by your force times maybe distance, no problem. But what is the work? Work is 1,000 is equal to your force times the distance, which is 25. So you divide by 25, divide by 25. So you end up with 40. These are newtons is equal to the force. But you know very well that force is given by mg. That one, that formula you might have seen. So if our force here is 40, is equal to the mass, which is m, times g, which is acceleration due to gravity. Also, this one is known at times 10 or 9.8. 9.8. So when you reach here, you have 40 is equal to 10m divided by 10 divided by 10. So 4 kilograms is equal to our m. Is that fine, members? Let me know through the chat whether now we're okay. Okay. Okay, it seems people are very okay with it. Okay, now since members are very okay, we are going to do an exercise. We are going to do an exercise. We are going to do an exercise. So allow me to first stop sharing briefly, and then I'm going to ask you to come here, and then we do an exercise. Hope my screen is on. In the chat, I'm dropping a link that we are going to use to do, and we are doing it live. So that is the link. So I want you to just click and join using your name. So we are going to do this quiz. So when we get to 80 people, we shall start. The link is here. Let me also post it in your WhatsApp group for those who are not here, who cannot access it here quickly.
Good.
Okay, so I've said when we get to around, we are so far 49. I don't know why the rest are not joining. Just click on the link. Just click on that link or go to your web browser, say join my quiz, and then you put in that code. So when we get 60, we start. The rest, join. Just click on the link, click on that link. We have more 4 people to go and we start. Hope we are not leaving anyone behind. More 3. Mm, 2. More 2 people, click on the link and we start. More 2 people. We are 96. There are people who are still failing. One more person. Okay, we are good to start.
Wanji?
So now you're going to look and see how you have performed. So that's how you have performed. Shama, Abigail, yeah. And those are your okay. So allow me to say that we are going to end at this point. I'll send you some work for you to do on the group.